Welcome and thanks for being with us this afternoon. My name is John Bagnulo, and I'm really excited to discuss some of the more common cooking oils that many people rely on for a significant percentage of their calories and as a big part of their daily meals or menus. And this I think has significant application to both the average person that wants to be healthier, and I'd call that person the consumer, as well as the clinician who really wants what's best for their patients. And after we look at these objectives, these learning objectives, after we take a look at these, which are to identify what are those attributes of oils that really determines where they're best used and in what quantity. Looking at how it is some of these oils, they interact or influence our physiology, looking at some of the benefits that have been demonstrated and some of the also potential risks associated with eating certain oils on a more regular basis, and then trying to summarize what has been shown about these oils over the last couple decades. So those are our objectives, and after we get through that, it's important to understand how it is this discussion this afternoon is assessing cooking oils. And I would put first on that list the ever important ratio of omega-6 fatty acids to omega-3s. Now, with all of these cooking oils, because all of these that we'll be discussing today for the most part are plant-based, we're not going to get into any of the animal fats. All of these are really going to be based or rooted in linoleic acid as the source of omega-6 for the most part, and the alpha linolenic acid content will by and large describe the omega-3 levels. The longer chained omega-6 fatty acids such as arachidonic acid, those are really only found in animal products, and the same is true with the longer chained or highly polyunsaturated fatty acids, often described as HUFA, H-U-F-A. Those fatty acids such as DHA and EPA, those are only found in animal products for the most part, marine mammals, fish, things along those lines, as well as in grass-fed animals. But the conversation this afternoon, we're really focused on plant oils, and many of these plant oils are highly sensitive to temperatures, higher temperatures, and so that really can have a great deal to say as to where they're used, how they're used, which cooking applications. And along the lines of the omega index, it's important to understand that across all mammals, there are very narrow or tight windows of what we call physiological acceptability with respect to cell structure and the phospholipid bilayer, this lipid raft theory. All the membranes, not only on the outside of a cell, but all of the membranes for organelles are made up of these phospholipids, and the lipids in our diet have a huge influence on the way these different membranes are comprised. And, in essence, what we construct these different membranes from in the way of the dietary fats that are represented in either larger or less significant quantities, that will influence our cellular physical structure and will have a great deal of influence on how various aspects of cellular physiology function because of that. Many of these fatty acids are the primary building blocks for eicosanoids. These are hormones that can either promote clot formation or reduce the likelihood of forming clots. They can be very productive, clotting stimulants. They can also help with vasodilation, or can lead us more in a direction of vasoconstriction. And of course, they control the inflammatory process in several different ways. And then lastly, it's important to look at the stability of cooking oils and how they resist oxidation. And that's not only with respect to how that might influence cellular physiology, but also what might happen with prolonged cooking times or high temperatures. So we're really limiting the conversation this afternoon to these 5 attributes that are possessed by different cooking oils. Now, I think the next question is, well, why is this such an important topic? And I've got a few slides that will really illustrate the rapid increase of oil consumption. Now, the slide says vegetable oil, but I want to make sure we start off, everybody with a clear understanding that these oils are not coming from vegetables. These are, for the most part, coming from seeds, nuts, legumes, but not vegetables. And to a lesser extent, certain fruits. The olive, of course, is a fruit, and technically, and that's obviously a significant source of global oil supply, as are coconuts and palm fruit. Those are also fruits, and the oils produced by those, different fruits are, again, very significant. But the term vegetable oil is often used in reference to oils that are largely produced here in North America, which would be oils such as sunflower oil, safflower oil, canola oil, soybean oil. And so that being said, if we go back, to 1961, so, we're roughly talking about the past 50 years here, you can see that the calories from these plant oils has risen steeply from 276 calories on average to now levels in excess of 650 calories. So while they haven't tripled, they're certainly approaching that. And there's other ways to look at this. If we want to go back to 1970, and I think that's a really interesting time, to get this type of image. A lot of this has to do with early American Heart Association guidelines, which really encouraged the consumption of more of these seed oils over animal fats and even tropical oils. And so that had a large, influence on what we're seeing in this slide, which is that if you go from 1970 to 2010 and you take a look at where significant percentages of calories were coming in the average American diet, you can see that grain products rose very sharply, almost a 50% increase. And of course, fats and oils did as well. And the fats and oils, going from roughly 340 from 1970, again, not 1961, but just from 1970, it approached, a level just short of 600. Red meat stayed about the same. Dairy products have gone down. Vegetables have gone down slightly. So those are the changes from 1970. Again, fats and oils on the rise. Another way to look at that is if we look at what's consumed now versus 1970. In the year 2014, the average American was getting approximately 1/3 of their calories from fats and oils, or a quarter, around 25%. Some demographics were getting a third, but the average American was getting about 25% of their calories from fats and oils, and that's a very, very significant increase from 1970. Now, in the last 10 years, with an increased emphasis on plant-based, again, plant-based oils, plant-based foods, you can see that we can really quantify where these calories were coming from 2000 to 2010. Really no changes in the amount of calories coming from animal-based fats. You can see 41 calories to 44 calories at the very bottom. Very, very similar levels across all animal foods. But what you'll see is that some of the bigger increases here were going to be distributed really across a few things, but certainly plant-based oils have risen as much as any other aspect of that kind of plant-based component. So we're eating more and more oil, and those oils, if you look at the slope of the curve, it is the steepest slope, meaning it's the most rapid or sharpest increase in consumption of any food. Some things have gone down, as we've already described, but cooking oils, which is the red line here, just above corn sweeteners, that's the one that has the steepest slope, indicating the most rapid increase in consumption. So that's a little bit of an overview on where we've come from, where levels are now. Now, anytime there's a rapid increase in the consumption of any food group, we can dive into the different substances and components to that food group, and we can find where the influence is on human health or on human physiology. And of course, the fatty acids provided by these plant oils are very bioactive. They, as we mentioned earlier, they're going to lead to the production of these eicosanoids, and eicosanoids come in different series. The series 2 variety is often looked at as the more pro-inflammatory. They really encourage platelet aggregation, and those series 2 eicosanoids go by the names of things like leukotrienes, which are formed when LOX enzymes or lipooxygenase enzymes cleave those specific fatty acids out of our phospholipid bilayer, and they're at that point used to generate these leukotrienes, a type of eicosanoid. And then there's cyclooxygenases, which will cleave those same fully formed essential fatty acids and produce either prostaglandins, thromboxanes, prostacyclines, and these, again, of the series 2 variety are pro-inflammatory. Of the series 1 and 3 variety, they're anti-inflammatory. And what we need to understand is that it's really important, there's a balance. There's a balance in circulation with respect to these eicosanoids. It's when we're out of balance that we can end up with something along the lines of a chronic disease or a compromised immune system. So this is the path. These are the pathways. This is the slide that really depicts or illustrates where these increased levels, dietary intakes of oils and fatty acids has had that potential role to shape human health. Now, most of the oils, these what we refer to as seed oils, and again, this is going to represent 90% of the oil consumed in North America, are going to be largely omega-6 dominant. That means that if you look at the different types of fatty acids that comprise these oils, they are largely made up of linoleic acid, an omega-6 fatty acid, and have, with only a few exceptions, have very, very low levels of alpha linolenic acid, or the omega-3 fatty acid. So this just gives you an idea of where some of these oils are. With the case of sunflower oil, 2/3 of the fatty acids in sunflower oil are omega-6 or linoleic acid, and there's next to nothing in the way of omega-3. So that's an example of a predominant omega-6 rich oil. And those types of levels create a physiological imbalance with chronic consumption, meaning eating them, on a regular basis. And that's one of the reasons we have, one of the highest ratios of omega-6 to omega-3s in our diet in North America. It has a lot to do with these oils for the most part. And, of course, some of the byproducts of agriculture growing these oils, such as corn oil, that is often lends itself to the similar fatty acid ratios in animals that are raised on these types of foods. Now, our ancestors, whether you're going back 10,000 years or you're going to go back 50,000 years ago, our ancestors had dietary levels of omega-6s to omega-3s, or somewhere around the area of 3 to 1. It might have been 2.8 in certain areas of the world. It might have been as high as 3.5 in other areas, but that's largely a function of the food availability in those regions. But our ancestors typically had a ratio of around 3 to 1 omega-6 to omega-3. So you can see there's a significant discord between current dietary omega-6 to omega-3 levels and what our ancestors ate. And there's always a consequence for that. Once we start to deviate significantly from our genetic blueprint, so to speak, in terms of what we've been exposed to on a dietary front, and that really invites imbalance across all organ systems. And it's worth noting that the research would suggest 3 to 1 or better, meaning maybe 2 to 1, and certainly 1 to 1 would be indicative of a ratio of omega-6 to omega-3 that would be necessary to ameliorate or reduce inflammation. So this just gives you a picture, and you can see that flaxseed is unique. Flaxseed oil is the only oil here where you have a dominance of omega-3 fatty acids in that particular oil, and that's why I think flaxseed oil is so unique when you look at the clinical research regarding that. and various biomarkers that equate to better human health. Now, what we know is that there are so many different biomarkers used to now predict cardiovascular events, risk for cardiovascular disease, risk of myocardial infarction, all-cause mortality. And many of these biomarkers have some ability to reflect inflammation. So tumor necrosis factor, as an example, would be a clear biomarker indicating more inflammation with higher levels of TNF. And if you can look at this, this slide, which sometimes takes us a moment to fully appreciate, you can see that on the x-axis, the horizontal x-axis, in this slide, you can see that EPA plus DHA are broken down into quartiles, where there are greater and greater percentages of energy coming from that combination of omega-3 fatty acids in a population's diet. So the fourth of these quartiles on the top is represented as 0.19. That's 0.19% of energy, and you can see that that would also be in close proximity to the lowest quartile for linoleic acid, which is an omega-6 fatty acid provided by these oils that we're talking about today. You have the lowest amount of dietary omega-6 fatty acids in the form of linoleic acid. You have the highest intake of omega-3 fatty acids in the form of DHA and EPA, and that produces the absolute lowest level of TNF. Now, this has also been shown with C-reactive protein, another very valuable and well-respected biomarker that reflects inflammation. And in the back corner, you're going to see the lowest levels of omega-3s, and you're going to see how that combines with the highest levels of linoleic acid. So that's the tallest bar or stack at the very back of each of these models, and it reflects the highest levels of TNF. And they're almost twice as high as what you get in many of the other models. So, that's just an illustration that really shows the relationship that's been observed with human dietary studies in a significant number of people. So with that said, then we can look at the omega-3 index. Again, this is just the first method of assessing the influence of a cooking oil or a plant oil on human health and in application to a regular part of a diet. You can see that the ratio of, the omega-3 index is simply the ratio of omega-6 to omega-3 fatty acids, has the greatest overall risk reduction to sudden cardiac death, most often caused by obviously an MI or myocardial infarction. And you can see that it's very, very significant in comparison to things that we are well respected, such as total cholesterol to HDL. It's along those lines, if not better. So it's, there's certainly a significant body of clinical evidence indicating that this omega index is a very valuable method of quantifying the influence of a regular component to a human diet on health. And this has really led to a complete revisiting of what we call the lipid theory, which was that, plant oils, animal fats, this lipid theory suggested that eating fats that raised total cholesterol levels was the mechanism by which certain fats and oils increased one's risk for heart disease. This has been revisited on a regular basis and is now questioned on so many levels, and it has led to a theory or hypothesis that is in the process of supplanting the lipid theory, which is that, look, myocardial infarctions, heart disease are not simply a function of cholesterol in the blood. They are more often than not a function of inflammation, damaged artery walls, oxidative stress, And it's the confluence of these processes that really drives the etiology of heart disease, not simply the production of cholesterol and the amount of cholesterol in one's blood. So, this is being referred to as the oxidized linoleic acid hypothesis. Well-known cardiologist, very well respected, with great, great careers in the area of lipid cardiovascular research, like Jim O'Keefe. They have put together, and this is an excellent paper. I would consider this to be one of the most valuable papers for anyone to look at here over the last couple of years, that really lays out the 20, and I only, for the sake of our time together, I only outlined here the first 6. There's 20 mechanisms by which linoleic acid and an imbalance of linoleic acid in the diet and consequently in the body drive heart disease. So I really encourage you to take a look at this paper when you get a chance. It's available online. And it just really goes through where the oxidation starts to be responsible for heart disease and increased risk for not only heart disease, but other conditions that we'll look at here in a while. So the omega index also reflects the pro-resolving versus pro-inflammatory processes, and those are not solely responsible for heart disease. I mean, they have an enormous role on brain health. This also is an excellent paper looking at the role of linoleic acid on brain inflammation and on different processes that we associate with the aging brain, as well as neurodegenerative disorders. Keep in mind, these omega-6 fatty acids, as I started to describe initially, they are being consumed at an unprecedented level. It's only in the last 50 years that we have consumed these with any type of significance. And it's really only in the last 30 or 40 years, again, with an effort to try to, correct the population's risk for heart disease and some of those early guidelines. That's when people really started to turn to these omega-6 based oils over other fats and oils that had been used more traditionally. So, it's important to note that we're seeing changes on so many different in so many different areas of medicine, and certainly neurology is one of those. And there are so many factors that would influence the aging brain, but the amount of polyunsaturated fat that our brains are exposed to now and that are being incorporated into nervous tissue, again, it's at an unprecedented level. So when it comes to those areas of health that I would say most clinicians, as well as just health conscious consumers, are unaware of, one of those areas is on the influence that omega-6 fatty acids and the oils that, again, are the primary sources of those, have on bone health. This is an excellent study. It's an animal study, but it looks at how olive oil supports bone health, and how sunflower oil really tries to, in an effort, this illustration really tries to just depict as best it can the changes in rats from age 6 months to age 24 months, which is, typically the best way we can use that as an analogy to human health. That someone going from their teens to their early 80s. In terms of the rat model, if you can extrapolate that to the human. So it's looking at the aging process in rats, and really had 72 rats in each arm of this animal study. And what you see is that the olive oil, really there's generally a maintenance of bone health over the lifespan. But because of the elevation in isoprostanes, again, that's a type of eicosanoid that can be either pro-inflammatory or less inflammatory. Olive oil does not generate excessive levels of these eicosanoids of the pro-inflammatory series, whereas sunflower oil, because of its omega-6 content, tends to drive up production of these isoprostanes, and those really tend to cause a loss in bone mass, because just keep in mind, over the course of human evolution, we really have evolved several different mechanisms which increase our chances of survival when we're in trauma or stress or have had injury. And one of those is mobilizing calcium to help with the clotting cascade. to provide immediate patchwork, so to speak, to damaged areas. And getting calcium out of the bone is something that can save our lives at a time of acute injury. But the chronic inflammation that can be generated or driven by an excessive amount of omega-6 fatty acids, in the case of this animal study, it was used in the form of sunflower oil, that causes over time a net loss in bone mass. And this is, again, the same study, just really looking at what you have overall for changes, negative changes in bone mineralization, and how that also is reflected with PTH, parathyroid hormone levels, at any given age here, differences between olive oil and sunflower oil. Now, again, we can take a look at another animal study. This had roughly 70 to 80 animals in each arm of the study. They used olive oil. The researchers used olive oil, sunflower oil, and fish oil. And you can see that the bone loss in the animals, those 75 animals that received sunflower oil, as around 10 to 15% of their diet over the course of their lifespan, they had lost roughly 280 micromoles of bone mass, primarily in the jaw, whereas there was only 80 in the olive oil consuming animals and around 160 in the fish oil. So, again, the type of oil, whether it's highly polyunsaturated, whether it's an omega-6 dominant oil, or it's more neutral in the case of olive oil being made up of mostly monounsaturated fats with very little omega-6s or omega-3s, has a huge influence on things far greater than just heart health. It has a huge influence on brain health and as well as bone mineralization. Now, that always begs the question, well, how is this? How is it that the types of fatty acids found in these oils can be so far reaching that it's also going to influence bone health? Let's just take a look at a moment of the most common fatty acids delivered by plant oils. Oleic acid is at the top. It's called an omega-9 fatty acid because of where that first double bond occurs, which is after, that 9th carbon. Then you have linoleic acid. It's an omega-6 fatty acid because of the placement, again, of that first double bond, and it's polyunsaturated because you have more than one, right? 2 double bonds. Then you have alpha-linolenic and omega-3 fatty acid, right? You've got 3 double bonds occurring, and the first one's after that third. And then you have some other less common fatty acids that are provided. Gamma-linolenic acid is found in things like borage oil, as an example, evening primrose oil, and it is an omega-6, but it's very unique. It's much less frequent in terms of its distribution in plants. So it's a more rare type of omega-6 fatty acid. It does have very unique influences on our physiology and on cell membranes. And then you have stearidonic acid, which is a more polyunsaturated omega-3 type fatty acid. But again, it's fairly rare as well. So, where we're going with this is these fatty acids have a very unique chemical structure, and because of that, they have a very different shape. Each one of these has a different shape if we were to look at them on a 3-dimensional model. So what that means is that when they're incorporated into what we call the phospholipid bilayer, they will take up different amounts of space, and it will cause a remodeling in that area of the phospholipid bilayer. Now, that phospholipid bilayer, again, that's a huge part of the mitochondria and mitochondrial health, is the way these fatty acids are incorporated and the influence they have on that membrane. Some of these are very susceptible to reactive oxygen species. Some of these are going to influence whether or not molecules are more efficiently transported into and out of the mitochondria. So they have a huge influence on mitochondrial health and the aging process of that really important organelle. And what you see here is that the way you can look at this is the number of spheres that occur below the dotted line. Those should be looked at as advantageous. So you're getting very little changes or remodeling going on within that mitochondrial membrane. And in the case of example B here, which is linoleic acid, the omega-6 fatty acid, it's really the only omega-6 fatty acid represented here that is common in plant oils. You can see that all of the spheres are above the dotted line, so there's significant remodeling, and they get very, very far. For the most part, they get further and further away from the mean. So there's a significant amount of remodeling that takes place. This is that lipid raft theory, where, again, the more of this remodeling you have and the greater the changes in this mitochondrial membrane, away from what we'll refer to as baseline with respect to a mammalian model. You need mostly monounsaturated fats here, and you need a certain, you need balance between the omega-6s and omega-3s. And of course, there's a very significant amount of saturated fats in this lipid model as well. The further and further we start to deviate away from that, the more that invites pathology to the mitochondria. And we know that the mitochondria is pivotal to so many types of chronic disease as well as cancer. So, the disruption of this through the incorporation of excessive amounts of omega-6 fatty acids really starts to drive disease processes. And that may be why, for those of you who are familiar with the PURE study, I mean, again, I consider this to be one of the better studies conducted in the last 20 or 30 years. That PURE study, again, that looked at 18 populations from 18 different countries on 5 different continents, and there was, roughly 52,000 participants. And what we know is that the hazard ratio goes down with greater and greater percentages of energy coming from monounsaturated fat. But with polyunsaturated fat, you see that the curve starts to increase slightly after around 6 or 7% of calories coming from polyunsaturated fat. So this would really speak to this topic, which is there's a limited amount of polyunsaturated, or room for polyunsaturated fat, and it certainly has to be balanced with respect to omega-3s and omega-6s. Well, how is it that, that disruption, how is it that it leaves us more predisposed to, let's say, mitochondrial pathologies? Well, one of the primary mechanisms is that particular organelle, the mitochondria, and its membrane has to be extremely resistant to oxidative stress because of what's generated internally or within the mitochondria. And when it is not resistant to oxidative stress, it becomes, in essence, on fire, and you end up with mitochondrial membranes that no longer contain that redox system that is necessary there. And there's other mechanisms at work as well that, are often unique to certain oils. And we'll start out with canola oil. Canola oil is really interesting. And in the mid 1950s or so, it was not allowed to be in the human food production. It was also not allowed to be in the feed developed for livestock because of what had been observed, because it contained a substance known as erucic acid, which in animal studies had been shown to be harmful to reproductive health as well as cardiac health or cardiac muscle. And then plant breeders, for the most part in Canada, developed a rapeseed plant which had less erucic acid. They got it down to around 2% of the overall fatty acid content. And that's when canola oil started to appear more regularly. And then it wasn't really until the early 1990s when it was produced in much, much larger quantities and started to supplant other oils such as olive oil across the American and Canadian populations. Now, canola oil is unique. It's really unique. It has a significant amount of monounsaturated fat, which is generally very good. It also has a significant amount of polyunsaturated fat, much more so than something along the lines of olive oil. It does have some omega-3s, so it's more balanced than, let's say, sunflower or safflower oil. But what's unique about canola oil is that it requires specific enzymes for it, in essence, to be detoxified at the hepatic level. And that may explain what's been observed with respect to both animals and humans and the influence that canola oil consumption has on insulin sensitivity and a HOMA-IR score, which is a homeostatic metabolic assessment of insulin. How well is insulin serving us? How efficient is that insulin in terms of helping us control blood glucose levels? And what's been shown, and you'll see that you have a control group on this slide, then G1 and G2 are looking at Nigella sativa. That's called black seed or black cumin seed oil. That's very rare. That's only used in certain countries, with any type of regularity. In the Middle East, it is something that's used in certain dishes in very traditional recipes. So it is It is more widely used in, again, certain areas of the world, but in North America, it's seldom used unless it's being used as a supplement. Then you will see, as you move further on, you're going to see that you have, with respect to G4 and G5, this is olive oil, and G6 and G7 are canola oil. And what's being observed here is the G4 are the control. Okay, these are the control animals. G5 are the animals that have diabetes. And after 3 days, you can see that there is very little difference in the animals, the control animals that are getting the olive oil, from the 3 days to 4 weeks, there's very little change in their glycemic control. But you can see that if you go to G5, these are animals with diabetes, you can see that after 4 weeks, there is a significant reduction in fasting blood glucose levels. There's much better glycemic control in the animals that receive the olive oil for 4 weeks. Now, again, this is really pertinent with respect to our diabetes populations that we may work with. G6 are the controls. These are the animals that do not have diabetes, and there's very little difference in glycemic control from day 3 to day 28 in those animals. However, with the animals, and this is G7, with the animals that have diabetes, you can see that after 4 weeks, there's a significant increase in blood glucose levels in the animals that received the canola oil versus the olive oil or the control diet. So again, control diet, no changes significantly, very subtle changes, if all, and then when you get into olive oil, there's a reduction, and then when you get to canola oil, the animals had less glycemic control, higher fasting glucose levels. Now, interestingly, that's been observed as well with adult women who have type 2 diabetes. There were some very similar changes across olive oil, canola oil, and sunflower oil, but the one that is really interesting is if you look at HOMA-IR, you can see that it went down. It went down significantly for the women with diabetes consuming the olive oil. However, it went up slightly for those women consuming the canola oil, and as well as insulin. Insulin went up significantly, much more than the researchers had predicted. And because of that, this is yet another very important point in the effort to collect data on the influence of these different oils on not just heart disease, not just inflammation, but on things such as glycemic control and on the etiology of diabetes. Now, in Australia, young Australians were found to be 2 to 3 times more likely to develop metabolic syndrome than those, and those were, again, young Australians using either canola or sunflower oil on a regular basis. That was defined by 5 times a week in their cooking or in salad dressings, as opposed to those Australians who used canola oil and sunflower oil seldom to rare and used predominantly olive oil, coconut oil, or other types of oils. So we have different ways of looking at this, from the animal study to the clinically controlled intervention study with adult women with diabetes, and then we have this more of an ecological, epidemiological study looking at information is coming in, and we're getting a better and better picture of really how limited that window of physiological compatibility is with some of these seed oils that, again, they've become a very significant percentage of the calories at many of the populations we work with. And when it comes to the very unique effects on the brain and beta amyloid tangles, beta amyloid immunoreactivity, which we know is it's really intertwined with the development of Alzheimer's. You can see that the canola oil fed animals, they have, when you look at the cerebral cortex, they have a much greater percentage of that cerebral cortex area that is defined as immunoactive to these beta amyloid plaques, beta amyloid tangles, however you want to describe them. So, in different areas of human health, both canola oil and sunflower oil appear to, carry a certain amount of risk. There's some downsides in these different areas of physiology, and that, makes us ask, I think, the $1 million question, which is, why? Why is it we're consuming more of these oils as opposed to, as this slide illustrates, a very traditional oil, in the case of olive oil, that's been consumed for at least 8,000 years with regularity. It just has a much greater level of physiological compatibility with our phospholipid bilayer. It doesn't contain the pro-inflammatory, imbalance with respect to the omega-6 and omega-3 ratio. It contains other substances, and if it's a minimally processed oil, which most olive oil is, if it's extra virgin or cold pressed, very minimally processed. You can see that, for patients with ulcerative colitis, and that's Crohn's disease, ulcerative colitis, that's a significant percentage of our population. You can see that there are major improvements in the frequency of symptoms, the severity of symptoms. This score is depicted. You can see that the olive oil is the dotted line, which is there's a sharp reduction in the severity and frequency of symptoms for these patients, as opposed to those on the canola oil. There's a very slight decline. Now, it's important to note that when we look at these oils, often people refer to the smoke point of an oil, which is how high of a temperature can it be brought to before it, in essence, starts to smoke, and you start to detect that burning taste that you don't want in a recipe, and that we know is generally associated with the production of harmful substances. This will give you an idea. As you scroll across these oils, you can see extra virgin olive oil here is on the left, far left. And what's interesting, you can see the smoke point, and then you can scroll down and you can start to see things like the amount of polar compounds. And those polar compounds, those are not good. Okay, those are in essence lipid peroxides, and they generate free radicals. So this is a great slide to look at what are just the initial characteristics of oils before they're heated. And you're going to see that, I hope this will clarify some of the confusion around oils, because I think many of us have heard different things about oils in terms of the temperatures they'll stand up to, what's the best oil to use when you're going to be frying something versus sautéing. What you see here is that some of the oils have fairly high smoke points. However, when you look at the amount of polar compounds in them, it's not as though you really want to start from that place. Rapeseed oil is the RO. You can see that you've got olive oil in 3 different states, right? You got extra virgin olive oil, you got virgin olive oil, then you just got regular olive oil, and you can see that there's a change in the smoke point, and a lot of this has to do with the way that they're refined. You can see avocado oil is here. So as you start to, if you can think about it this way, as you start to, let's see here. As you start to make your way across, you'll end up with coconut oil over here, which is got the highest, it's got the highest smoke point here. It's got a very low amount of polar compounds, and that's a function of just how it's a saturated fatty acid that just doesn't really have the double bonds available to form free radicals. So that's initially before any cooking. And then you look at the oxidative stability at about 110 degrees Celsius. It's slightly over the boiling point. And you can see that, again, you got coconut oil, you got olive oil. They have they have excellent stability points there. But then let's take a look at what happens. This is after heating. Okay, so this is after heating, and that's, again, you're talking about 110 degrees Celsius. That's a fairly low overall temperature in terms of what's used in most heating systems. When I say heating system, I'm talking about a cooking system, food processing. You can see that the final amount or percentage of polar compounds is very high in grapeseed oil, that was abbreviated GO. Canola oil has the highest, and then in third place you have sunflower oil. So those are, again, canola oil, highest amount of polar compounds after heating, followed by grapeseed oil, which, again, I said that I think this would really help clarify some of the confusion, because you'll often hear that grapeseed oil is one of the healthiest things, one of the healthiest oils to cook with, and that's because it has a high smoke point, but that doesn't necessarily mean that it's healthy. And you can see that it has a very low level of oxidative stability in comparison to something like olive oil, which is here, and coconut oil, which is here at 50.27. So, again, you have to go much further than looking at the smoke point. You have to look at the amount of polar compounds that might be found in an oil, both pre and post cooking, and sometimes they are they're not aligned with the particular oil's smoke point. So when we take that into consideration, we think that 98% of North American canola oil is what we call RBD. Now, RBD is a food science, agricultural term for refined, bleached, and deodorized. Now, why is it oils are refined, bleached, and deodorized? It's because they are, in essence, the food industry wants an oil that doesn't have a strong taste, that is refined to the point where it's degummed, so it's not going to cause any problems in terms of separation. It's not going to require, larger amounts of something like an emulsifier. So, food processing, typically utilizes oils that are highly refined. And when you start to look at the temperatures involved here, again, 100 degrees Celsius, 120 degrees Celsius, and you look what happens in the bleaching and the deodorizing process, you can see that the temperatures required for deodorizing oil, and again, it sounds funny for us to talk about deodorizing an oil, but you would be amazed at the consumer preference in processed foods for oils that do not have any flavor. So this is why, in an effort to explain this is why these oils are so heavily processed. You can see that the temperature is more than twice what was used if we go back to generate these types of polar compounds. So it's not as though these oils are going to avoid that type of thermal processing. They're just not. They're going to be exposed to very, very high levels of heat. And because of that, they produce excessive amounts of these polar compounds and lipid peroxides. And that is part of the reason why they are harmful to human health when they become a regular part of the diet. Now, again, you're going to say, but I've seen the heart symbol on the bottle of canola oil at my grocery store. I have read that canola oil and sunflower oil are heart healthy. All of this is based on the fact that those oils tend to lower serum cholesterol levels. And I just want to state that because that's a point of confusion. Just because a food lowers our cholesterol levels, it doesn't mean that that food is compatible or is beneficial to human health. And that is really how narrow I think the scope has been with respect to evaluating these oils over the last 40 or 50 years. So it's important to remember that. Now, here's what's interesting, because again, we're trying to explain the mechanisms that could explain why it is many of these industrial seed oils are being associated or are being shown to cause changes in physiology. And here's one that many people are also unfamiliar with. When an oil is refined, bleached, and deodorized, now keep in mind, we have high levels of temperatures, plus we have other processes taking place. With bleaching in particular, you have the addition of certain substances to remove pigments, in addition to removing flavors and impurities. So when these oils are refined, we form trans fatty acids. So look at the levels of trans fatty acids that are occurring. Now, everybody understands trans fatty acids are harmful to human health, right? That's why, so many states and across, North America, we've done an excellent job of basically legislating hydrogenated oils and trans fats out of so many processed foods and out of the fast food industry. But what a lot of people don't realize, if we use partially hydrogenated soybean oil, that's the lowest. The lowest here you'll see on this chart, you'll see that it's about 50% trans fat on average. Well, canola oil can be up around 3.5% trans fats. Now, again, that's not like partially hydrogenated soybean oil, but when canola oil becomes a significant percentage of a population's diet, that's 3.5% of every tablespoon of canola oil being comprised of trans fats, and that's a risk factor. Sunflower oil, it's not as bad, it's only around 1%, but olive oil, now again, olive oil is rarely refined, bleached, and deodorized. I mean, olive oil, even if it's not extra virgin olive oil, may have some thermal processing, but you won't find olive oil that is as clear as vegetable oils that have absolutely no pigment in them, no flavor. Olive oil tends to retain some modest levels of pigment, modest amounts of flavor, even when it's not extra virgin or cold pressed. Keep in mind, cold pressed olive oil or extra virgin olive oil, it's mechanically pressed, that's it. And in some cases, it's not even extensively filtered. That's why it contains so many of the beneficial polyphenols that we know really help us. But all these other oils, soybean oil, sunflower oil, canola oil, walnut oil it's not as predominant an oil. These are highly refined to get to that clear state with no flavor. And when that happens, you're going to form these trans fatty acids. So that's another mechanism. And that leads us to kind of a summary statement thus far with these oils, which is, look, if we take a look at things such as the omega balance, yes, olive oil, extra virgin olive oil, it may have a level of, let's say, 7 to 8 omega-6 to omega-3s. So it has an omega index of somewhere in the area of 7 to 8. But the levels, the absolute amounts of omega-6s and omega-3s provided by olive oil are very, very low. And that's in sharp contrast to something like canola oil, which one might look at and say, hey, it's got a favorable omega index. It's around a 5 or a 6 of omega-6 to omega-3s. However, the amount of omega-6s provided by canola is much, much higher than what is found in olive oil or avocado oil, for that matter. So we've got olive oil, avocado oil, coconut oil. All three of those will stand up to at least modest amounts of heat, around 212, somewhere around the boiling point. All three of those will stand up to that temperature without the production of excessive free radicals or lipid peroxides. So they have excellent and very diverse cooking applications and uses. Flaxseed oil, even though it's very well represented in the way of omega-3s, it has an excellent omega-6 to omega-3 ratio. It's actually 1 to 7. Which is really the inverse of what most oils are. It does not stand up to high temperatures or extensive cooking time. So that's an oil that we really want to reserve for making salad dressings out of, or using in recipes that will not be exposed to high levels of oxidation or cooking. And then we've got other sources of fats, such as grass-fed dairy butter or butter, ghee, which is, in essence, it's butter, which it's been heated, but it's had most of the protein removed. These can also be very well balanced with respect to omega-6s and omega-3s. It can be a 1-to-1 ratio in grass-fed butter, and they can stand up to higher levels of heat than even olive oil or some of the other oils. So those are really your best choices when we start to account for all of these different influences that fats and oils have on health and what happens in the cooking process. And then on the right-hand side, we really have the oils, which unfortunately have become such a significant percentage of calories in the North American diet and are imbalanced in one or more ways. So just a summary here of where things stand. Now, it goes a little bit beyond, what happens, let's say, when we simply cook an oil in the absence of any other ingredient, which we've already looked at with the heating of those oils. What we know is that each oil also, based on its polyphenol content, how polyunsaturated it is, we know that some oils tend to cause a net loss in the human body's antioxidant abilities or defense systems, because of really they're going to be a net loss or a net draw on the body's reserves because of the lipid peroxides that they contain. Those have to be detoxified by enzymes such as glutathione peroxidase and superoxide dismutase, abbreviated SOD, when they get to the liver. And then we know other oils, in the case of olive oil, contains robust amounts of polyphenols, does not contain those lipid peroxides. So there's a net gain with respect to antioxidants and the bioavailability of really important polyphenols and phytonutrients. And that's what's depicted in Dr. Anaya's study. This is a great paper. This was done in Barcelona, which is at the University of Barcelona. They've got one of the best food science and human nutrition labs in the world. And they really take a close look at food cooking systems. What are the interactions that take place between certain nutrients when they are part of an overall ingredient matrix? I mean, this university has done some of the groundbreaking work on the formation of advanced glycosylated end products when animal proteins are burned or grilled, and they showed that if those animal foods are first soaked in something like lemon juice or lime juice, that you can really ameliorate or prevent the formation of those compounds. So they're always, you know, along with University of California, UC Davis, they've got a phenomenal, you know, food science and human nutrition program as well. But the University of Barcelona showed that when traditional vegetables, and you know, tomatoes are actually a fruit, but we'll just throw them in the category of vegetables for the sake of this conversation. When vegetables are cooked in or with olive oil, that the olive oil facilitates a much higher level of net bioavailability in the end dish or recipe, meaning that you can quantify the antioxidants and the polyphenols in tomatoes and in garlic and in red onions, and you go down through all of the traditional vegetables that many populations around the Mediterranean saute, you know, with olive oil. When you take a look at your starting points and you include the olive oil because it contains antioxidants, polyphenols, and you look at the bioavailability of those individually, at the end of normal traditional cooking times, this is sauteing for the most part, you have a marked improvement in the bioavailability across the board. You know, like the best way to describe this is food synergy. You know, so this is the paper for those of you who might be interested in learning more about this, and you know, it really puts olive oil at the head of the class. And I think, you know, probably many of you are aware of that. It just has the greatest overall body of clinical evidence, of epidemiological evidence, ecological observations, however you want to look at it. You can go from the micro to the macro. Olive oil is unmatched in terms of its compatibility with human health. And, you know, coconut oil is very similar, although coconut oil is less, it's not as well understood at this time because we started in the 1960s with a real misrepresentation of tropical oils in North America. They were almost always highly refined, sometimes hydrogenated, in the case of palm oil. And tropical oils got a really bad name for the first, you know, 3 decades or so that they were present in the North American food supply. However, we knew that populations in areas of the world could get as much as 50% of their calories from coconut or palm fruit, and they were very, very healthy. You know, those oils were less refined. You know, that's a big part of it. And again, they were being evaluated, unfortunately, solely on their influence on total cholesterol levels. But when we look at, you know, coconut oil and palm oil, and I think there are some really important ecological points to the conversation around palm oil. You know, I think it's really important that palm oil be produced from sustainable palm plantations where, you know, we're not having deforestation take place in an effort to produce more palm oil or grow more palm trees. But, you know, that aside, coconut oil, palm oil, butter, predominantly saturated fats, really hold up well to cooking, and there's a much higher level of physiological compatibility for those fats and the fatty acids that they're comprised of in our tissues than there ever will be for the levels of omega-6 fatty acids found in most of the industrially produced seed oils here in North America. So, you know, with that, I really want to thank you for your interest in this. It's one that I'm always looking forward to sharing this information with folks. And you know, at that point, I'd love to answer any questions that you might have.
Thank you, John. That was an excellent presentation. If you could just click to the next slide. And I'll just make sure I touch on this and we'll get to questions. But for those of you who are new to us, we did just want to share that Functional Formularies has some new products. In addition to Hope and Nourish, they have a peptide formula and a keto formula. Both are certified organic and plant-based, sourced from the cleanest growers with no artificial ingredients. And they do also contain hydrolyzed pea protein and organic coconut MCT oil. So if you're interested in more information on these, please contact sample@functionalformularies.com. Yes, I can hear him echoing too. I'm not sure why that's the case. Let's see. But yes, please reach out and see if you can contact them, and we'll get to some questions. Okay, John. I'm not sure why I'm echoing. I'll just try to get through these. So, um, as far as, can you clarify what polar compounds are?
Yeah, sure. Polar compounds would be, again, I just want to bring everybody back at some point, as painful as it might be for some of our listeners. If you go back to organic chemistry, probably lost about 30% of our people there in terms of interest. One thing that happens with these double bonds is that they are going to react with oxygen, and you're going to end up with what's abbreviated as an ROO. It's a polar compound, is best described as it's a peroxide, and because of that, it's less stable, and it's basically a free radical in the form of an oxidized double bond. Let's leave it at that.
Okay, great. And can you also clarify, as far as coconut oil, can you share your thoughts on how it relates to heart health, brain health, and inflammation?
Absolutely. I look at coconut oil as being very compatible with all three areas. It's not pro-inflammatory. Again, I know I've said this in the past, but if you go to an area of the world, let's just use Sri Lanka as an example. Sri Lankans get 50% or more of their calories from coconut fat. Now, that could be coconut oil, that could be the coconut, other coconut products that contain very large amounts of fat. They have the lowest heart disease in the world. So we've got those kind of big picture macro models to look at, and then we've got the animal studies which show coconut oil, whether that you're comparing that to a control diet, you're comparing that to other oils, it's not pro-inflammatory. It does tend to produce slightly higher levels of serum cholesterol, and again, that's why it's maligned. That's why it's often looked at as a counter heart health oil. But it's just, having higher cholesterol levels is not. It's not really. It's not an indictment of an oil. And so I look at coconut oil as being excellent for brain health. I mean, it's about 65% medium chain triglycerides. Those really are beneficial to the human brain. So I really like coconut oil on all three levels.
Can you share the breakdown of fat that you recommend as far as total percent dietary fat, and then a further breakdown as far as what you recommend for saturated fat, etc.?
Yeah, sure. I think the human diet ideally should be made up of somewhere between, and it is variable depending on a person's age and their digestive ability. There's just so many factors that come into this. But typically humans do best with a diet that's somewhere around 45% fat. You wouldn't want it to be much lower than that, and then you'd want it to potentially be as high as 55% fat. These are, again, so 50% kind of being that average amount of calories coming from fat. And then when you look at that, most of that should come from monounsaturated and saturated fat. This is of the total fat intake, with roughly 5% coming from omega-6s, 5% from omega-3s. So you want to make sure those two are balanced, somewhere around no worse than 3 to 1, three parts omega-6 to 1 part omega-3. But I wouldn't want the polyunsaturated, the overall calories coming from polyunsaturated fat total to be much more than 10%. So hopefully that gives gives folks a decent idea of what that would look like.
And what do you think about people in the plant-based community that recommend that we should not eat any oil and only focus on whole foods with fats like avocado and nuts?
Yeah, I think that can work for some folks. I'm not against that at all. I don't think oils, there's no mandate or necessity to add oils of any type into a human diet. We can get excellent fat profiles from relying strictly or solely on whole foods. Absolutely. The one thing I would say is that if we are going to rely entirely on plant foods for our essential fatty acid levels, it becomes very difficult to maintain that balance between omega-6s and omega-3s simply because most nuts and seeds, as an example, are largely made up of omega-6s with very little in the way of omega-3s. Again, flaxseed oil, very unique in the fact that there's more omega-3s than omega-6s. So that's the one caveat I would put out with that if you're going to rely solely on whole foods such as nuts and seeds, that the balance can become a little elusive unless you're going to use something like freshly ground flax meal, with one meal every day to try to counteract or balance out the omega-6s. And with that being said, we do know that a significant number of adults cannot convert all of the omega-3s or the omega-6s for that matter that they get from certain nuts and seeds to what their body really needs. So that's where these having, whether it's fish 2 to 3 times a week, or it's something like pasture raised eggs or grass-fed meat, we know that you can often acquire significant amounts of omega-3s from those foods, and they can balance out some more of the omega-6s that might be coming from whole plant sources. But that being said, I don't think anyone has to use oils at all. Certainly you can get all the fats you need from whole foods. So I'd be totally aligned with that.
Where does almond oil fall in terms of omega-6 to the omega-3 ratio?
Very high omega-6 content in comparison to omega-3s. So while almonds, and this is also true of hazelnuts, although hazelnuts are a little bit better, they have a little less polyunsaturated fat, even though almonds and hazelnuts you do have most of their fat in the way of monounsaturated fats like we see with avocados and olive oil. They do have a modest amount of polyunsaturated fat, and most, if not all, of that polyunsaturated fat in almonds is in the way of omega-6s.
Thoughts on fish versus fish oil supplements?
I would definitely recommend eating fish over using fish oil supplements. Fish oil supplements typically contain DHA and EPA, and that's it. And at a later date, I'd love to share with this audience what's found in oily fish in the way of fats and oils that are not found in fish oil supplements. There's so many fatty acids beyond DHA and EPA that we know in looking at subcutaneous fat samples or biopsies from different populations. And these are fatty acids you can only get from eating whole fish. You're not going to get them from any supplement. And they are associated with marked improvements in longevity and a huge risk reduction. And that's why eating fish 2 to 3 times a week is so protective. In every study that has looked at fish consumption, whether you're comparing the addition of fish 2 to 3 times a week to an otherwise entirely plant-based vegetarian diet, or you're looking at the inclusion of fish in an omnivorous diet, fish is always advantageous at 2 to 3 times per week. We don't get those kind of results with fish oil studies. I think the jury's still out on fish oil, and some researchers that I have a great deal of respect for, such as Sanjay Ghosh, he's a PhD, does amazing work on fish oils and other oils and how they change the microbiome. It really raised some serious questions about fish oil. So I'm definitely in favor of eating fish 2 to 3 times a week, but not taking fish oil.
Okay, and then I'll group a couple of others. There's a lot of questions just overall on avocado oil, your thoughts on pros and cons, and then also generally about grass-fed butter, how it relates to heart disease, and if grass-fed butter is different than just regular butter that's not grass-fed.
Sure. I mean, I think avocados are a phenomenal food. There's just so much we could say about avocados, and one of the things that makes them so beneficial are the plant sterols that are found in them. And when you take an avocado and you produce avocado oil, there's a significant amount of refinement. And I'm not putting it on the same level as the refinement that would take place with sunflower oil or canola oil, but it is still refined. You lose a lot of the benefits when you take an avocado and you take that to a point of oil. You don't get that same type of loss with with going from olives to olive oil that you do with going from avocados to avocado oil. Avocado oil requires a little more refinement to give it a longer shelf life, and so because of that, I'm not as big a fan of avocado oil as I am, let's say, olive oil or coconut oil. Avocado oil does have a higher smoke point, and it has a very neutral flavor. So those are two things that make it desirable for people in certain recipes. But I think it's okay. But the slide that I showed on polar compounds and stability showed that avocado oil was not, despite its higher smoke point, it didn't convey any other benefits, and it was not advantageous to other oils. So I'm not against it, but I think it would be something I'd use on a limited basis and only with select recipes.
And then the second part, similarly, just discussing butter, regular butter versus grass-fed butter, and the impact on heart disease or heart health.
Absolutely. Butter is a great source of predominantly saturated fats. Again, I know sometimes, it's been ingrained in many of us from a young age that saturated fats equal heart disease. Luckily that's not the case, and it does take some reschooling, for lack of a better description, on most of our behalfs. But I would say that butter, in addition to being very compatible with human health and our physiology, it's a great source of N-butyrate, a short-chain fatty acid that we know is great for every aspect of our health, especially brain health. So it's around 3 to 4% N-butyrate by weight. That's great. That's even if it's not grass-fed butter. Grass-fed butter has a 1-to-1 ratio of omega-6 to omega-3, so it's well balanced. It contains fat-soluble vitamins such as vitamin A and vitamin K2. Those are very beneficial substances. And again, studies like the Rotterdam study over in the Netherlands showed that people who ate more butter and more full-fat cheeses, they had, again, higher levels of vitamin K2. They had much lower levels of myocardial infarctions and cardiac events in the 10-year follow-up period. So I look at butter as something I think it's great. As long as people can digest it well. It is one of the more difficult to digest fats because of the need for more bile, a little more hydrochloric acid in the upper GI. So but I think it's a very, very healthy added fat to the diet. And so I am in favor of that. If it's not grass-fed, look, it still has, by and large, it's still going to be mostly saturated fat. It's still going to have the N-butyrate because it's something that's being, produced by a cow to be the ideal source of nourishment for its young. So because of that, there's a little bit of a bottleneck, and you don't end up with the imbalances that you might suspect, despite what the animals are being fed. But I would still advocate for eating grass-fed butter whenever possible.
Okay, there's a lot of questions, so I know this is a big topic that hopefully we can address them later. But since we're close to 15 minutes over, I'll just end on this last one about sourcing. So can you speak to the purchasing or quality? Can you speak about the purity of various olive oils that are present on the market today?
Yeah, Catherine, that's a great question, and it's one that I get asked, frequently. And I would say this: over the years, and we can go back, you want to go back 30 years, or you want to go back more, there have been frequent examples of, basically tainted, or I'd say tainted olive oils, in terms of that they were not entirely olive oil. These were typically sold as kind of large conglomerate type oil producers, where you had oil being pooled with, whether it was rice bran oil or it was canola oil, and all these different blends that have, kind of been discovered over the years. I would make sure with the olive oil that if you're going to buy it on a large scale basis for an institution, you want a certificate of analysis on that olive oil. And you want to make sure that olive oil has been tested, that lot of olive oil has been tested, so that you are getting some level of confidence that the testing has taken place, and this is what's been shown. The monounsaturated fats should be 70% of that. If it's not, then you know it's been tainted with some other kind of oil. And then, you know, as a consumer, I always buy olive oil from a single estate. That doesn't mean it has to be expensive or difficult to find. Single estate olive oils are available at every grocery store across North America. It'll say on the bottle, and those have, if any, they've been extremely rare of examples of something being in that bottle or that tin of olive oil that was not supposed to be there. So if you source olive oil from a single estate, whether it's Italy, Greece, or Spain, you're on the right path. If you're a bigger, if you're in charge of a food dining service type facility, then you want to make sure you get a certificate of analysis on your olive oil. And I would still try to get olive oil from a single estate. When you do that, you're much closer to the grower. You got much less of a chance of something going awry in the ultimate production of that and how it's packaged.
All right. Well, thank you, John. That was an excellent presentation, and thank you everyone for sticking with us as we went over for those questions. As far for registered dietitians, your CE certificate will be emailed along with the reference list later today, and we look forward to you all joining us next time. And thank you again, John.
Thanks a lot, Catherine. I appreciate it. And thanks everyone for being part of this today. Take good care.